Hey guys, so today's video is going to be all about, it's kind of an 8.2, 8.3 combo, since we're not doing proofs on this at the moment. And it's going to be all about similarity postulates. Okay, so if you can remember back to triangle congruence postulates and all of that, how we had things like ASA and AAS and SAS and SSS. This is going to kind of remind us of that, except instead of congruence that we're showing, we're going to be showing similarity and deciding based on information that we're given if two shapes, or two triangles, excuse me, can be similar to one another. And again, these only work for triangles. When we've talked about similarity before this week, it's been kind of in terms of triangles and quadrilaterals and things like that. Today we're only applying it to triangles, and there are three different postulates we are going to look at. The first similarity postulate we are going to look at is SSS similarity. Okay, so for two triangles to be similar with SSS, we're going to need to show that the corresponding sides are proportionate to one another. So SSS similarity says the triangles are similar if all three pairs of corresponding sides have the same ratio. Okay, all three pairs of corresponding sides have the same ratio. And so to kind of get an idea of what this is going to look like for us, we're going to do an example involving SSS similarity. So, example, this is triangle ABC, and there's our sides, and this other triangle over here, not drawn really to scale, DEF, is going to have side lengths 10, 8, and 6. Okay, so in order to use side-side-side similarity at all, we need to have all three side lengths on both triangles. So if you don't have all three side lengths on both triangles, you can forget about SSS. But on this one, we're lucky we do have all three sides on both triangles, so we're good to go here. Then what you want to do, you have to figure out which sides are going to go together, which pairs will correspond with each other. And so the easiest way to tell this is to label your sides big, medium, and small. So on this triangle, we have big, medium, small, because 3 is the smallest, 5 is the biggest. Same thing over here, big, medium, small, since 6 is the smallest and 10 is the biggest. Then what you want to do is take your big side from this triangle and divide it by your big side from this triangle. So we want to go 10 divided by 5, which gives me 2. Then I want to take my medium side divided by my medium side, 8 divided by 4, which is also 2. And then I want to take my small side divided by my small side, so 6 divided by 3, which also happens to be 2. So since all three of these ratios end up being the same, we can say yes, they are similar. We could also be asked to write a similarity statement for these two triangles. So for example, if I wanted to start with triangle CBA, I would say that it's similar to triangle blank. We would need to be able to figure out which one goes with it. So this big, medium, small thing also kind of comes in handy when you're writing your similarity statement, because if I start at C, looking at C, C is between the big and the small side. So I want to find the angle over here that's between the big and the small side. So in this case, E is between the big side and the small side, so E would come first, right there. Then B comes next. B is between the small side and the medium side. So looking over here, F is between the small side and the medium side, so F would come next. And then lastly, by process of elimination, letter D would come last. Okay, so that's SSS similarity. The only thing you have to be careful of is notice how all the numbers on the top here are all from this triangle, and all the numbers on the bottom are all from the other triangle. You want to make sure you're consistent just like that. You want all the top numbers to be from one triangle and all the bottom numbers to be from the other triangle. So that's really the only thing you have to be careful of there. And again, most of the time, especially in the IXL section you're going to have for homework today, you're going to be checking yes or no for most of these questions. You're not going to be really writing the similarity statement, although you could be asked for that at some point. Really what we're looking for is, are they similar or are they not similar? And so if all three of these ratios are the same, yes, they're similar. Okay, so that's SSS similarity. The second one is going to be SAS similarity. So just like with SAS, when we were doing triangle congruence, you do have to have the same setup here, where you have two sides and then the angle that is in between those two sides in order to show SAS similarity. So we would say two triangles are similar if they have one pair of congruent angles and the sides on either side are proportionate. So the sides, or the pairs of sides on either side of that angle are proportionate. 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 Okay. So again, it's easiest to see what's going on in a situation like this if we use an example. So what if we have something like this, where we have, let's see, we'll call that PROAT. This side length here is 4, this one is 3, this one is 6, and this one is 8. Okay. So the first thing that we want to notice about this picture here is that we've got some vertical angles going on. Right here, remember when lines cross, we have vertical angles, and vertical angles are congruent to each other. So that would be our set of congruent angles. So we do have side, angle, side, side, angle, side. Awesome. So side, angle, side similarity is now a possibility because we do have an angle with two sides on either side of it for both of our triangles. Okay. So, since we've got the vertical angles, now all we have to do, this becomes a lot more like the SSS case now. We want to label which of these from this triangle is the biggest and the smallest. So if I'm looking at just this triangle here, 8 is the bigger one, 4 is the smaller one. Looking at just this triangle here, 6 is the bigger one and 3 is the smaller one. So now what I want to do is the same thing that we did with SSS similarity. Now I have to check my proportions. So I'm going to put 8 over 6, big side over big side, and then 4 over 3, small side over small side. And we want to check and make sure that these are the same. if I reduce the fraction on 8 over 6, we do get 4 over 3. If you're not 100% sure, try dividing the numbers and see what you get as a decimal and see if it's the same decimal that you get when you divide these numbers. If so, like in this case, these are the same. So we would say, yes, they are similar. Awesome. So now we know they're similar, and we could do something a lot like what we did with SSS similarity when we want to write a similarity statement. I could be given a statement starter, for example. ROP is similar to blank. Okay. So starting with R, we know R is between the small side and the one that we didn't label. So the one over here that's between the small side and the one we didn't label is T. So T would come first. Then O is between the large side and the one we didn't label. Over here, A is between the large side and the one we didn't label. So A would come next. And then P would come last. Notice how P is in the same location in each spot because P is that angle that is the same on both triangles. All right. So again, SAS, SSS, they're very close to one another in terms of what you have to do in order to show similarity. Proportionate sides, and then in this case, you have to have one angle. Okay, there's one more similarity postulate that we are going to look at today, and it's actually the easiest one to use, and it is called angle-angle similarity, or AA similarity. Okay, so AA similarity says two triangles are similar if two pairs of angles are congruent. Okay. So there's a couple different ways that this can look. I'm going to start with, for example, TOP, and then we'll have CAR. And we're going to be given some information here. We'll say this angle is 80, this one is 60. We'll say this one is 80 and this one is 40 degrees. Okay, so for AA similarity, you have to know that two pairs of angles are congruent. Now first, we know that we've got one pair of congruent angles to start with. These are both 80. So that's good. But these two angles are not the same. They're close, but not quite, right? 160, 140, so that's not even really actually that close. But if you ever given just two angles and one of them is the same and the other one is different, the other pair is different, you need to check the third angle. So remembering that the angles on a triangle add to 180, we have to go 180 minus, in this case, 80 minus 60. And if we do that subtraction, we get 40, which tells me that this remaining angle here is 40. And now we have two matching pairs. We have angle P matches with angle A. And it just so happens if I were to find the missing angle here, if I went 180 minus 40 minus 80, we would get 60, which matches up angle O and angle R. So not only do we have two pairs of matching angles, we actually have three. which is the case all the time actually. If you ever have two triangles that have two pairs of congruent angles, really that means that all three angles have matching pairs in both triangles. Anyway, so if we were to start a congruent statement or a similarity statement, we say yes, these are similar because of angle-angle similarity. So I might be given a starter like triangle CAR is similar to triangle blank. And we know that C goes with T because they're both 80 degrees, so T would come first. Then A is 40 degrees. A goes with P. And then R goes with O. Okay, so that's an example of angle-angle similarity. Okay, so now we've got our three similarity postulates. We have SSS, we have SAS, and we have AA. And that's pretty much all you're going to be asked to do with any of those three. In these three cases, we all had similarity for each of these. Before we end here, I'm going to go over an example of each where we end up where they're not similar real quick. So on all of these examples, they were similar. On the ones I'll show now, we're going to see ones where they might not be similar. Okay, so last couple of examples here. A, B, C, R, S, P. We'll go with 12, 8, 9, 6, 8, 4. Okay, so on this one, we're going to check for SSS similarity because we have all three sides on both shapes. So I'm going to go label these big, medium, small, big, medium, small. So the big one over the big one, 12 over 8. Medium over medium, 9 over 6. Small over small, 8 over 4. And to check that these are the same, you can either reduce the fractions, or you could also just divide them in a calculator and get a decimal. Either way, 8 divided by 4 is 2. 9 divided by 6 is 3 halves, or 1.5. 12 divided by 8 also is 3 halves, or 1.5. And what do we notice? One of these things is not like the others. So if even one of these is not the same ratio, we say no, they are not similar. Okay. The same thing goes for the side angle side version of things. If one of the sides pairs does not have the same ratio as the other, then they're not similar. So the other one that I'm going to go over is an angle-angle case where we see ones that are not similar. RC. Okay. And on this one, we'll have, this is 90. This one is 70. 70. And we'll say this one is 60. Okay, so for this one, we do have one pair of angles that matches. Now we need to figure out if the third angle here matches with the others. So if this angle C is 90 degrees, then we're good to go. Or if this angle T is 60 degrees, then we'd be good to go. So let's find out. Let's go 180 minus 90 minus 70. And in that case, we get only 20. That means that this angle T is 20 degrees, and we do not have two pairs of matching angles amongst these here. Even if we went 180 minus 70 minus 60 to get this missing angle here, we would get 50, which means that the two triangles are just not similar. So we'd say no, not similar. Okay, so sometimes you'll end up with them being similar, sometimes you'll end up with them being close but not quite similar. Okay, so that is everything for today. Your homework is going to be in IXL, and it's going to be a lot of questions just like these. They're going to show you two triangles, and they're going to ask you, are they similar or are they not similar? And so you have to decide and then check the box. Okay, if you have any questions, I can help you out on Monday or in office hours. Otherwise, see you guys later.